here we go, guys. Here's a video lesson to go along with the applications of logarithms. So with applications of logarithms, let's do a quick little review question here. But the main focus of this lesson is going to be this kind of stuff where you're applying logarithms. So this the applications of log stuff down here. So it's going to be scientific applications where log is the kind of property, and so our skills allow us to solve real world problems. So pH scale, looking ahead here, the decibel scale, you'll see, I guess it's the bottom of this page here, the decibel scale, and the Richter scale, are the three examples we'll look through. But we'll need the kind of skills that we've worked on here, so I'll go over the first part with you. This is from the solution that's posted on the Jensen site. I'm going to help make sense of what he wrote here. So one of the things you're going to want to do when solving for x, right? You want to get x all together, right? So you're going to gather the log x type terms. It's not just x, but so how that next line was gotten was by adding log base 2 of x to both sides. Right, so that led to that next line. And then what happened to go from this line to this line? Well, if you have the addition of 2, you can have the product of 2. That's your product law that we've passed recently. So that makes sense. And then he switches to this. It's something you're supposed to be able to do, where you're supposed to be able to see that and say, oh, okay, well, that means that this is the number that you need to write the argument as a power of 2, right? So there's the argument, and 2 to the power of 4. That's supposed to be able to understand that that's what log means. It's nice also to be able to, let me just write that out as well, or yeah. So this means, right, that 4 that's equal to in the end there is the power of 2 needed to write the argument, which is 6 times x as a power of 2. So basically as to the power of something, well, the something is 4. Right, that's what it means. Or if you're following along with what I've said before, it's good to recognize the value of converting between exponential form and log form of the inverse. So this out here. So if you look at that, you can say, oh, okay, so this is my usual log base a of x equals y. If you convert that to the exponential form, say, okay, my exponential form b y, and so you can match things up. Obviously, the base is still the base, and so it's going to be a 2. The y value, you can see it's 4, so it's 4. The x, of course, is, grab an extra color here to size, yeah, so that. So we've got that. It's going to be, yeah, it's right there. So that's where your x minus 6 times x would go. So yeah, you can see that is the same as that, right? So there's more than one way to go to that next line. At that point, all that happened was the distributive law. The x went on to both, giving x squared and equals 6x. Then he took away 16 from both sides, giving us this quadratic. So basically think of that as convert to standard form. Convert to standard form of quadratic. Recognize it as a quadratic, convert to standard form, work with the quadratic properly, of course, right? So that does factor, of course. And if you're thinking of factoring the way you've been shown in the past or possibly whoever else you might have had here. Then you'd be looking for factors of 16 that add. You put the n numbers, this is the trick way of doing it. So the 8 and the 2 you can see would allow you to get a 6, right? So basically, as long as that is the negative there, you're going to get a 6 and so on. So if you had other than numbers other than 1, you have to multiply together, get -8 and 2, which adds to be -6. Or hey, I've got the right numbers, good to go. Anyway, so those are your factors. Of course, as usual, zero principle here, where these are your two solutions. So basically, you've got x equals the 8. From that, if you needed to see it, we could do it as x minus 8 equals 0. Add 8 to both sides, x equals 8. Same thing for this one here. The other solution would be x equals -2. Usually we just do the opposite sign for those because it's pretty easy to see once you've done it a few times. And notice, of course, here that these are referred to, this one here, right, is rejected, he says, but that's because it's an extraneous root. It's a root that you just can't, doesn't make sense in the context of the question, or the math of the question, really. That's an extraneous root, so we reject it, and so we say, okay, so value of x is satisfies that, it's just 8. So on to applications. So my note for this one, I want to make sure you recognize that don't be afraid, don't be intimidated. Let me put that there. Don't be intimidated by the sentence of the equations, right? Quite literally, as they have on t-shirts now and then, is Jeep. I've got Jeep on mine. I want that is keep calm and do that, right? So keep calm, do the math. In other words, I'm going to show that it doesn't matter what the equation is you're given. You're given an equation. You're going to put numbers in. You're going to use math skills to solve. Okay. With given information here, we're going to refer back to it as we go through this. But this is the equation that you now have been given, right? And it's not a case of memorizing the equation. It's just a case of being able to use math skills to solve and work with it. So the first example just says tomato juice has a concentration of this. Well, you're really just substituting that in and evaluating, right? So basically that number can go in there and then just evaluate. So you're doing literally just doing log of decimal 0.0001, and you got a -4, and so the equation results as 4 as the pH. So easy peasy, same thing for this one, even if the numbers are ugly, put it in, calculate log, get the value. Okay, so the first two are just a case of evaluating. This one is the first one where we actually have to solve. So we need to solve. This one's a little lower math skills coming on this one. That's supposed to say this time. Almost does. Yeah, so if you look, I should point out too, you're given a pH of 3, so pH equals 3, and we're asked what the concentration is. That's the symbol for concentration in science, but concentration of H plus ions, right? So in your usual strategy in math, look at what you're given, what you're looking for, and pick an equation to do with it, right? And that's the one that you were given on the previous page, which was pH equals negative log of H plus concentration, right? So you can see what happened there on the first line was literally that 3 was just plugged in there, just like I would do here, right? So I got the 3, and so solving out here, you would have just multiplied both sides or divided both sides by -1, giving you the -3 equals the log. And then at that stage, you have choices as to how you work. You could do it the way where you say, oh, I know that this is the exponent needed to write this thing as a power of 10. So 10 to the power of the -3 is what it is. That's just understanding what log means. Or or you could recognize that this thing is a y equals log base a of x. And so we can convert that to equals log base a of x. First to be the exponential form, which is x equals a to the y. So if you're looking at what's what here, the y value is -3. So the y value is 3. The x is the h plus concentration, and the a, as I said before in class, there the h is the base, so it's easy. So yeah, that leads to this formula, right? And so you just have to evaluate and get this answer. Concentration is decimal 0.001 moles per liter. Okay. Next question, seemingly a little bit more intimidating, maybe, but again, don't be afraid. Just do the math, right? So put in numbers and do the math, right? You're either solving or evaluating. Doesn't have to be stressful. You don't have to memorize the equation. You just need to use it. So this question says how many times as intense, right? So let's point out what we have here as given information as well first. First of all, on the table, whisper right here was 30 and a normal conversation level, right? So you were given information here is 30 decibels and 60 decibels. So that's good to recognize. And you know, if you went with your usual problem solving strategy, you're going to say, okay, that is my, my initial loudness decibel scale, and my final loudness in the decibel scale. And I've been asked for 3 times as intense, right? Well, that is, of course, the I. They have written as I2 divided by I1. Whenever you're dividing a final by an initial, you'll find out the multiplication factor between them. Even in a money case, if you had $50 and now you have $100, 100 divided by 50 is the 2. You double your money. A deal. All right, so that's your 32 times business. And I don't need an X there, but that's times is intense. And so all we're doing is recognizing that this equation is the one that we can use. And so we put the numbers in, the 30 and the 60 and the 30 went in, and the what we're looking for is that one. So just evaluate, you get 30, and then divide both sides by 10. We end up with the 3. And so at this stage, it's the usual stuff. You understand log, it's base 10. So 10 to the power, right, is what this thing is. Or prefer like I do, this is your y equals log base a of x, converts to an x equals a log a to the y. And so the y is clearly the 3, and the a is the base, always, 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 and the x is your ratio, that we're looking for, right? So that gives us this line that Jensen skipped to, and you can just evaluate this thing and get that it's 1,000. Shows you the conversation is 1,000 times as hence. That's a whisper. That seems odd. Take grade 11 physics and I'll explain the meaning of it. But basically, it's surprising that the amount of energy in a conversation versus a whisper is actually 10 is 1,000 times as much. Whereas it only seems like it's, how much louder. While we're looking at a 30 to a 60, seems like it's twice as loud, right? But that's why the logarithmic scale is used. It helps relate how it seems in real life in comparison to the actual energy levels that are surprising. That's the physics aspect of it. Same deal for this one. We have, we were given this time the times intense. So the I2 over I1 was given to us as 32, and we were given the initial level, 85, asked for the resulting sound levels that happen on the snowmobile. it's more intense than regular traffic. So yeah, you're given that information, and again, they're just plugged in, boom, boom, and you start to try and solve it out, right? And so this actually just evaluates as a number, because log base 10 of 32 is just known to be that's just a number. 10 times that number, add 85 gives you, so this is just a case of evaluate. My work here. Okay. And similarly, we're given this equation. Magnitude on the Richter scale is equal to the log of the intensities divided. So the intensity of one divided by this standard intensity level, they call it the I0. But again, it's just an equation that you're given, and you're going to be given parts of it. You're going to plug those parts in and calculate. So for this one, we're given what? We're given the magnitude. So equals 2.4 Richter scale. We want to know the how many times it's intense information. So I over I0 being asked. So obviously there it is as a variable to be able to solve for, and there's the 2.4 plugged in. And as usual, you know that this number is the exponent right there. It needs to be on 10 to give that value. That's just the meaning of log. Once you're comfortable enough with it, it should just sort of translate automatically. This y equals log base a of x, converting to x equals a to the y. Works as well, right? Because there's your y, there's your y, there's your y. Yeah, anyways, yeah. So you would just evaluate that thing, 10 to the power 2.4 gives us that number, and you're good to go. Conclusion statement in meaningful questions like this is always good. And the last but not least here, you're saying that it's 1,000 times as intense. And you can see they've given us this. And so boom, there it is. And then you just have to evaluate. Obviously you would go here and say, oh, what's the magnitude? Oh, what's the equation to do with this? What's the equation that was given to you for this question? I hope that helps. If you have any questions, come see me.